After that very abstract look at finding the formula for the chain rule, let's apply it for some specific functions here. So we've got our function here, y equals x squared plus 1 to the 1,000. So what we have to identify is what's the inside function, as I like to call it, the g of x, and the outside function, the f in our chain rule. So I'm going to write out all the details for the first several examples. So the inside function, which is the one that we called u, or g of x, here is not too hard to find because it's the one inside the parentheses. And we know by order of operations that we do parentheses first. So that's x squared plus 1. Our outside function, which is the one that we're calling y, and we renamed f of u. What is the outermost function here? In other words, what is the last thing you do? That's you raise it to the 1,000th power. So u to the 1,000th. I'm going to stick with using the letter u here. It doesn't matter. It's a dummy variable. If you want to use x as well, that's fine. You just have to be careful to remember that somehow x is playing a different role here than it is up here. So what does the chain rule now say dy dx is? In our first form of the chain rule, it's f prime of u times g prime of x. So what is f prime of u? We've got u to the 1,000th. We're getting comfortable by now, I hope, with our power rule. So the derivative of that is 1,000 u to the 999. Chain rule says we're supposed to multiply that by g prime of x. So what's the derivative of g of x? That's derivative of x squared plus 1. That's 2x. But we shouldn't leave a u in our answer, because u is something that we ourselves introduced into this problem. So what was u? U was x squared plus 1. So x squared plus 1 to the 999 times 2x. So that's the derivative of x squared plus 1 to the 1,000th power. Let's think about how you would have to do that without the chain rule. There were two options. One, multiply this all out, expand it, FOIL it all out. You'll get 1,001 terms. You take the derivative of each of them individually, you've got the answer. Another option is, well, technically this is a product of 1,000 terms, right? So you could apply the product rule 999 times, get some huge mess, that would be correct. Of course, in practice, there's no way that you would do either of those correctly because you will make some mistake along the way. But what I like to think about is that imagine how messy those were. Somehow they each simplified down to this wonderfully nice compact expression here. That's pretty nice. Let's talk about how we would do this without writing all the intermediate steps down here, because in practice, that's what the stage we want to get to. We've got something to the 1,000th power. By the power rule, what's the derivative of something to the 1,000th power? It's 1,000, the same something, to the 999th power. But the chain rule says the new thing is we take the derivative of that inside something and multiply by 2x there. OK, let's try another example here. So y equals 2 to the x cubed. And just to be clear, what this means is 2 to the parentheses x cubed. Whenever we write something like 2 to the x cubed in math, that's what's understood, that the part up here is the inside function. It's not the same as saying 2 to the x cubed, because there we would just write that as 2 to the 3x, right? Why would you bother to write 2 to the x? If this meant 2 to the x cubed, you would just write it as 2 to the 3x. That's not what it means. 2 to the x cubed means this. So let's identify our inside function. That's what you would do first. So if somebody asked you to evaluate this, say at x equals 4, the first thing you would do is take 4 and cube it. So the inside function, which we're calling u, or g of x, is x cubed. And the outside function, which we're calling y, or f of u, is what? That's 2 to the u. That's the last thing you would do to this, whatever input you were given. So what does the chain rule say? Chain rule says dy dx. We're supposed to start by taking the derivative of the outside, f prime of u, times g prime of x. So the derivative of f of u, we've got an exponential function, so we have to remember to use our exponential rule. So that's 2 to the u times ln 2. But the chain rule says you're not done yet. chain rule says you're supposed to multiply by the derivative of the inside, so the derivative of x cubed, which is 3x squared. I really like those exponential functions. 3x squared. But again, we shouldn't leave a u in our answer, so we should rewrite this as 2 to the x cubed ln 2 times 3x squared. So just a reminder that in both of these cases, as we talked about before we started doing any of these examples, the inside function doesn't change. The x squared plus 1 is inside here. It's still inside here. The x cubed was the inside function here. It's still the inside function here. We didn't try to put the derivative inside there. And if we want to do this without writing out all the details, what would we say? We've got 2 to the something. What's the derivative of 2 to the something? It's 2 to the same something, ln 2, by our exponent rule. Chain rule says multiply by the derivative of the something. When we were doing the product rule, I think we did an example that had this. And in that time, we didn't have the chain rule yet, so we needed to rewrite this as e to the 5 raised to the x. But I made the comment at the time that that's typically not how people do it. They normally think about this as a chain rule problem. So let's do this with the chain rule. So what's our inside function here? If somebody gave you a value of x, like 3, what would be the first thing you would do to that x? I hope you agree that you would multiply it by 5. So that's 5x. And then the outside function is what you would do next. And that is e to the u. So then what does the chain rule say the derivative is? It's supposed to be f prime of u times g prime of x. E to the u, one of my favorite functions because it is its own derivative, as we very excitingly figured out last week. And then what's g prime of x? The derivative of 5x is just 5. Except that we shouldn't leave a u in our answer. Make it e to the 5x times 5. And you can check that that's the same answer that we got last time, except that we had written 5 here. We had written it as ln of e to the 5, which simplifies to 5 because of the inverse function rules there. If we wanted to do this without writing out all the steps, we've got e to the something. What's the derivative of e to the something? It's e to the same something, except the chain rule says, now take the derivative of that something, so times 5. All right. What is the novelty in part D here that we are seeing for the first time in the chain rule? What is new that we haven't had to deal with yet? What's new is that our inside function is a product. So we're going to have to use the product rule inside the chain rule. We can combine these rules as much as we like. So in this case, the inside function is a product. So the inside, which we're calling u, or g of x. And if you don't want to write out all these details, if you're already feeling you're at the stage where you can just sort of look at this and start writing out the derivative, go for it. X to the 4th times 5 to the x. And the outside function so what's the outside function here? It's 3 to the u. So what does the chain rule say? So already we're going to, let's see, f prime of u times g prime of x. They don't make chalk like they used to. What is f prime of u? This is 3 to the u. So this is 3 to the u times ln of 3. But we know we're going to have to replace the u by something else, right? So what are we going to replace the u by? X to the 4th, 5 to the x. So now that we've gotten some practice, let's just do it that. And we'll do it like that. And we'll skip that intermediate step of writing the u. So we've got 3 to the something becomes 3 to the same something ln 3. Now times what? We're supposed to take the derivative of the inside. But as we said, the novelty of this particular function is that the inside function is a product. So to take the derivative of this, we need the product rule. And remember, the order doesn't matter for the product rule, so you might write this in a different order than I'm going to do. I'm going to take the derivative of the first one first, so 4x cubed, and then multiply that by the second piece, 5 to the x. And then leave the first piece alone, x to the 4th, and take the derivative of the second piece, for which we need our exponent rule, 5 to the x ln 5. So is there anything wrong with what's written on the board? Something that you would lose half a point for. We're missing some parentheses, right? We need to multiply this entire thing. This entire thing is our g prime of x. So we're supposed to be multiplying all of this stuff. But order of operations would say we multiply all these things together first, and then we multiply these, and then we add. We're really supposed to multiply all of this stuff there, so we need those parentheses. So please be careful with the parentheses. Let's talk about how we would do this one without having written out all the details. We've got 3 to the something. The derivative of 3 to the something is 3 to the same something, ln 3, but the chain rule says you're not done yet. Chain rule says you have to take the derivative of the inside function. And in this case, the inside function happened to be a product, so we had to use the product rule when we took its derivative. And this is what we got, since we're now product rule experts from last week. Is that good? Want to try one last one? What's the novelty of this one? Similar to the previous one, this one we had the product rule inside the chain rule. This time we have a product where one of the pieces is a chain rule problem. So this part involves the chain rule. So let's suppose that we just want to take the derivative of this part sort of off on the side. So what's the inside function there? Is what we're calling u, or g of x, is x to the 7th plus 8. And the outside function there is something to the square root, right? So u to the 1/2 power. So when it comes time in the product rule to take the derivative of this is where we'll make use of this stuff. But in this case, it is actually the chain rule inside the product rule. So we apply the product rule first. So the derivative of a product, we can take, the order doesn't matter. So let's say we take the derivative 6 to the x first, 6 to the x ln 6, and we just multiply by the square root. That's the first half, the easier half in this case of the product rule. Then the product rule says we leave this first piece alone, the 6 to the x, and now we take the derivative of this piece, and that's where the chain rule comes in. So we've got an outside function, u to the 1/2. The derivative of u to the 1/2 should be 1/2 u to the negative 1/2. And the u is our inside function, right? The x to the 7th plus 8. So that doesn't change on the inside. So if you were tempted to put 7x to the 6th inside here, you were taking the derivative of the inside too soon, the most common chain rule mistake to make. So this is the derivative of the outside. And then we're supposed to multiply that by the derivative of the inside. So the derivative of x to the 7 is 7x to the 6. So already, because we have this product rule down pretty well from last week, we were able to get into some pretty complicated functions and take their derivatives. And for the rest of the night, the rest of the week, we're going to be expanding the number of functions that we can take derivatives of, so we'll get more chances to practice the chain rule once we have trig functions and log functions and that sort of thing. But for now, we have a check your understanding for you to practice the chain rule with the functions that we already know.